Last one, last session. Hang in there. I know the standard thing to say at this stage of the afternoon is, I am all that is standing between you and your drink. Let's kick off. Always battle to find a metaphor for code quality, but I love joinery. So I don't know if anyone else is into woodwork and things sort of just beautifully done. So that's why I picked that picture. So yeah, I'm just as old as the Ark. I'm the founder of a software development company called KRS, and yeah, we have been around for 38 years. I'm a mom. Apart from woodwork, I'm also a keen hiker. But I think it's all that dev stuff. I'm hoping to share some experience with you. I just want to put out there the things that I care about. Now, I love a simple solution, and everyone talks about simplification, but it's not that easy, right? How do you know what's... And you know, we're all detail-oriented people here. I'm assuming most of my audience here are devs. And you guys care about the detail, and it's very hard to get out of the weeds and simplify. So we're not particularly good at this. I like this nice term, lowering cognitive load. Why make our lives more difficult? I'm going to talk to you a lot about that. And hell, I do not like surprises in code. I don't like surprises for birthdays and stuff like that either, but I really don't like them in code. I mean, if a method says, I calculate X, I don't want to find out it also did and Y, right? And those things for me is kind of things that I regard as code quality. It is not a complete list, but something to aim at. I'm expecting that we've got two audiences today. People who care quite passionately about getting things right. And also probably some people more at the beginning of their career who just like going, where do I start? I hear about all this refactoring, but it's intimidating. What am I allowed to do to code? So we'll try and answer both of those. I'm going to start with a little bit of learning from others. You can also get this list off my KRS blog. Software, A Philosophy of Software Design, is a lovely, gentle little book that mainly talks about simplification. So it's a really good place to start if you just want to get some pointers on that. And I'm also a big fan of DDD. Don't know how many of you know it. But domain-driven design. I'm seeing some like questioning looks. We'll talk a little bit about it as well, but it's a really nice way to organize code to align with business needs, with the domain. Right? And the person who wrote the book on DDD is a guy called Eric Evans, which is an exercise in masochism. It's just he's a hugely intelligent, very theoretical man. It's damn hard to know what to do once you've read it. But Vlad Khanonov has the most accessible, easy to read book, and especially if you're in the .NET world, absolutely recommend it. Code Complete is another one of my favorites. Maybe if you're starting out, it's a magnum opus. I mean, it's got everything you could ever want in it. So if you've got that level of staying power for reading, go and hit that one. How many people use TDD? TDD? Yeah. Some more. I think most of us have got to a point where we maybe try unit tests. TDD is getting, more in use. If you aren't there yet, if you're still curious about it, go and get the original book, Test-Driven Development by Example, Kent Beck. And for today, I'm also going to take some pointers from his latest little book called Tidy First. Oh, it's a small thing. And it's really easy stuff to do. So we'll pick up some of those. Then I threw in some historical ones, some slightly older books. The Mythical Man Month is often quoted for project management type work, adding manpower to a late project makes it later. Person power, I suppose. But it's actually, at its heart, it's an engineering book. So some really good pointers in there. And then the really old one, the classic, is Structured Design from Jürgen and Constantine. And I'm going to talk to you about coupling and cohesion from that. But I'm not really recommending that you read it, because unless you are really old, all the examples about tape drives and punch cards are going to be totally inaccessible. But we're still battling the same problems. Isn't that interesting? In software, almost every decision you make is a "it depends" answer. It's most frustrating. No one will ever give you a straight answer on what to do. It's always "it depends." Most of our problems are the so-called Goldilocks dilemma. Let me give you some examples. Well, things like, how much should I refactor? What is too long? What is too messy? And the fancy word I want to introduce to you is heuristics. It's just a nice name for the mental shortcuts that we create for ourselves, by which we make decisions. Now, I want to encourage you to start working out your own parameters for all these subjective questions. And not just yourself. If possible, you could have this conversation with your teams. Because if you would all agree what is too long, too messy, too whatever as a team, probably the code reviews would go a bit faster. Right, so mental shortcuts, plenty. You do it all the time. And if you see a fairly dark alleyway and you decide, I'll take the next road, that was, your mind had made a decision, too dark, right? So we do it all the time in life. And moving on to structured design. Everything we talk about in terms of complexity, we're just talking about it in human terms, right? The computer doesn't care. When we worry about code complexity, we're not worrying about it executing. We're worrying about our capacity to understand it and maintain it. So let's just keep that in mind. Everything is to make our own jobs easier. And that lovely word of mine, the cognitive overload. So I don't know how many things you can keep in your mind at once. What's your stack like? Mine's horrid. I mean, I walk through a door and I can't remember what I came into the room for by now. But if you are reading some code and you're going down the method and you come across a variable and you have to go, I can't remember what's in there, and you have to scroll back, you've exceeded your stack, right? You couldn't keep all of that in your head. So the general rule of thumb is that smaller is better for us. We're actually not really multitaskers. Sad, but true. Not even women. So the thing we're talking about from Constantine that I want to raise first is coupling. It's a really simple sounding thing. How much stuff is linked together? The old spaghetti, big ball of mud. That would be highly coupled. Many interconnections. And the worst of the high coupling is when you've got to know every bit of the path to understand the end bit. Loosely coupled is the good one, where things are quite black box, right? And they're not dependent. So B is not dependent on A. When you make a change in B, you don't have to go and check if you're going to break something in C or D or E, right? So coupling is the actual definition for it from Constantine and Jürgen is how many other modules are affected when you make a change. Now, it's all very well if you know to check. I make a change in B, I check C and D. Quite often we make a change, think that we've got all the coupled, all the dependencies, and then find we've missed things. That's the real problem with this stuff. My rock, apart from being a pretty picture, was just to show, unintended consequences. Let me split that thing. So the stuff that affects coupling, Complexity of the interface. If you have a method with 32 parameters, you're going to battle. Who's seen those? I mean, yeah, that shit happens. The types of information flow. So it's bad enough if data is pushed around, in your parameter lists and in your returns. But sometimes there's little flags that cause different rules to execute. And so depending on what all's moving up and down, it gets worse to understand. Number of connections is mostly relevant because change one thing, how much is affected. And then a sneaky one called common environment coupling. The easiest example of this is your database. You have all this lovely modularity in your code, hopefully. We all got there. It uses a common database. So someone does some change in the database and everything's broken. Yeah. And we don't even think about it sometimes in the code, how dependent we are. Remember, true microservices, each microservice is supposed to have its own database because of common environment coupling. So yeah, it's all this unexpected stuff. Right. Coupling. The other one is cohesion. So coupling was, what it's connected to. Cohesion is what should it be connected to? Where do things belong? So belong is subjective. You've got many ways of picking where things belong. There's a couple of bad ones, which you might not have thought about as bad, but I'll tell you why I think they're bad. If you've got a whole lot of steps that happen at setup, those web pages that have such a heavy load time, or maybe everything shouldn't have been grouped by startup. It should have been spread with sort of lazy load. So don't group things. Don't say they belong together because of timing issues. Yeah, that would be temporal. Procedural is also one we fall into that trap all the time. It's the same kind of code. So we put all our database access in one place. Now that might be legitimate, and it might not be. You must think about your needs. I mean, if you can abstract away from the database to a model, that's usually better. Sequential, it happens one after another. Yeah, all these things they're not a good reason for putting things together. The one that is put out there is the best one, is functional. So it's a business reason to be together. So if you've got a nice, clear mental picture of sort of classes and you think, well, this does belong with this. There's no surprises. Where would I look for it? And I found it. You've got it together. And the method I like for deciding what's functionally together is to look at the domain, which takes us back to that domain-driven design. Now, if you do look into domain-driven design, and this is not a talk about it, but add it as a technique for better code, there's a couple of things you must start with, all right? Ubiquitous language you can use even if you use nothing else. And this is the idea of a common language with your business users. So if they call this thing a whatever widget, you mustn't go and call it something else. And we do that all the time. We have our own language for things. Try and align with the business. And then that's going to be difficult, right? Because sometimes they're not that consistent. So you actually get them to agree that when they say invoice value, they don't mean the cost price, they mean a selling price with VAT and after you've multiplied by the number of the quantity, or whatever the rule is. But you all agree it. And then if they don't use it properly when they're telling you what they want in a report, you go, that's not ubiquitous language. What do you mean? And it just takes out so many, remember, it's us communicating again. All this clean code stuff is for us to communicate better. And ubiquitous language gives you the best thing. The DDD folks say that cohesion follows naturally if you follow a business function. It's a big, bold statement. Go try it and tell me if I'm wrong. That domain-driven design is a strategic approach to your code. Let's try a little example. I've got impact, how much good does something do, and how difficult is it? Now, these are just my views, my heuristics, okay? So adding comments might make the code easier to read. It's not very difficult to do, but you could probably argue that some comments actually reduce cleanness. They go the wrong way. Has not even a positive impact because they're stale. You can tell more read what it does. All right, let's try something else. Yes. You've got a new architect. If that doesn't make your blood run cold, you haven't been in the game long enough. And your architect has decided that we are going to bring in a new, something like entity framework. We haven't been using it before, we're changing to that. It's going to be a lot of work. Sometimes those kind of changes don't deliver the improvement that everyone thought. You've still got the crappy database, you've still got the performance problems, and now you've just got a model that you're fighting the whole time because, and I'm not anti-EF, right? It's the retrofitting of these things when you didn't design it that way. So low help sometimes for very big effort. And you've got to ask yourself that. What do I mean by major refactoring? You know those ones where we say to business, we say, oh, we have so much tech debt. Could we have a feature freeze for 2 months while we go and fix the code? Oh, I'm so anti these. It's kind of funny because I love refactoring. But first of all, business starts to fear the word tech debt. So you're not winning any friends. And then the team goes and they clean it all up. But actually, they've still got all the bad habits that caused that problem in the first place. So what we really want to do is we want to start learning to be, the scout rule. You go to the campsite and there's some paper and you pick it up and you leave it cleaner than you found it. And this works so well in code because you're only cleaning where you go. Now, we have a tendency, if you ever look at vault analysis and the check-ins, you'll find that some modules, some classes, and files are hit more often than others. So kind of naturally, you're cleaning where you go. And you'd be surprised how quickly you start to have actually very nice code. Yeah, you got 80% of, don't want to look at it in the background. And you can deal with that when you get there. So the Scout rule is a really nice way to refactor. So the major refactorings, I'm just anti because you haven't changed habits. What you need to do as a team is just always be refactoring. Okay, there was a high value, low effort one. It's the truth though. We're reading code. So make it read well. Give decent names to stuff. And again, no surprises. If the naming says invoice value, I expect it is my ubiquitous languages one. It's not some other one without VAT in it or without, lots of benefit. Cool. So if we're going to achieve low coupling and high cohesion as guiding principles, and we're going to think very hard about the fact that we read code way more than we write it. So everything we do is for readability. Let's look at some starting steps. The one quote is, clean code is simply code that is easy to read, understand, and modify by us. Okay. And Beck says, software design is an exercise in human relationships. Think about that for a moment. But we are expressing ourselves to the rest of our team. Okay? So when I say be kind to those who follow, I can mean be kind to yourself too. I mean, was that lovely little joke about, oh, look at this legacy code. I mean, which idiot wrote this? We'll go look. Oh, yeah, it was me yesterday. But, we come back to our own stuff and we're like, what did I do? And reduce cognitive load. One of my devs said, I must understand that the 9 a.m. hymn writes different code to 4 p.m. hymn. So, yeah. If you work with pull requests, a lot of people do, then consider splitting refactoring from changes, feature changes. Okay. Hopefully you know that. Small PRs are easier on the reviewer, but the nice formal term, review latency. You know, that's the bit where you beg and beg and beg for someone to come and, approve your PR. That one. If you've got very long latencies in the team, maybe smaller PRs will speed it up because it's not as big an interruption. But if that's not the problem, then maybe you do have to batch stuff, because once you got that reviewer, you intend to get all your stuff through. It's your heuristic. You've got to find out the Goldilocks, what's enough, okay? But always split the refactoring from behavior, because refactoring shouldn't change anything in outcome. So you want to prove that if someone runs the code before and after, they must get the same result. You can't go, oh, no, it's changed because I also added the new feature. And I'll do another little plug for test-driven development, because if you're refactoring and you've got no tests, where's your safety net? You're making these changes and you're just hoping that you haven't really broken anything. So if you don't have any tests, you could always, scout rule where you're working, make it cleaner. You could always add a test just for what you've got. Yeah, I know, it's not exactly a test suite, but it grows. Got to start with one brick somewhere, I'm not going to talk about TDD too much here. You'll go and learn it for yourself if you need to. So let's talk about the little tidy first book for a bit. I've picked out a couple of the hints, and we'll talk about them. But it's a drop in the ocean. There's a lot of really meaty things about refactoring and getting your code clean. However, that I think is what sometimes puts us off from starting. Okay, so I'm just giving people little places to start. You see, again, a Goldilocks dilemma. Somebody has probably told you in a code reviews, the PRs, the approvals, are excellent places to bring out the inner nitpicker. So an awful lot. I mean, really, the stats say that I think 90-something% of PR comments are just style ones. Everyone's got a damned opinion on style and how you could have done it better. So you've probably been told at some point is not to have multiple returns from a method. You may or may not. But if that's the story, a nice thing that is actually acceptable is right up front, if you shouldn't be in the module at all, in that method, use method, then typically we used to have if, the guard conditions, and the whole damn thing in the squiggly brackets. I'm a C sharper, sorry. I always think in terms of squiggly brackets. But it's actually quite legitimate to rather say if not, and just get out of there, but still don't have returns all over, Do them up front, make it quite clear that now we can continue, we're in the right place. Some of those code complexity stats, they count indents. Didn't really think it was such a bad thing to be indenting code, but they count it. And if your code's marching off the right-hand side of the screen, it's adding complexity, because you're going, now what does that, where's the, it's that if, right? Dead code. If you've seen this T-shirt, but it's absolute classic. I see dead code. I know, it cost us a lot of effort to write that code. I mean, almost all of us at some point have just commented out, kind of in case. I mean, they're going to want it back, aren't they? I mean, we put all this effort into it. Okay, that's what version control is for. Delete it. Don't make other people who are going to come and read your code scroll through all this stuff. Consistency, that's an easy one. Trouble is we all work in teams. And Jim's habits are different to Sue's habits, which are different to Sipo's habits. At some point, your code starts to look, it's confusing. Now it's being done this way. Is this actually repeating code, just done in a different way? These are things you have to do as team agreements there. You have to say, look, in my world, I'm mostly doing back end at the moment, we're going to write our link in the following style. Okay, we all do it. We're going to return errors from the database in a particular, we like Fluent or whatever it is. Okay, But you stick to it and you enforce that, and it just reduces load. So this was one in the Tidy First book that was a little deeper. Because so far we've just talked about surfacey things. The idea here is if you'd really love a method to work in a particular way and you feel like stuck because the old way, you can't change it yet, you create the new interface and you just sort of do an interpretation to the old. So that you can start using the way you would like it to work in your code as you radiate that out. You slowly, each of the things that call the old code, you reroute them to the new interface. And at some point, you can re-implement it in the new way because you've got rid of all the dependencies. But you don't have to say, sorry, you've got to wait 2 months because I've got to go clean up all of this. You just start with the way you'd like it. And okay, that pattern's got so many names. The strangler, it's named after the strangler fig plant because that like strangles its host. And that's what you're doing, you're strangling out the old code. It's also a strategy for getting to dry. You know what that one is, right? Don't repeat yourself. So again, it's a bit overwhelming. You come into an older project, and a lot of us are on, the brown fields, and there's repetition everywhere. But if you're going to go and try and get all of it out, you could break something because there might be just one thing in one of the repeating things that's actually a knot. So unless you've got really good refactoring tools, you just do that you have that same mindset. You extract to a method, you make it like you'd like it to be, and you only fix up all the other repeatings when you happen to work there. And you go, oh, I have a nice method for that. You can route them to common code. You don't have to clean everything up at once. I think that's the point. Strangle out the rubbish in small steps, right? Okay, this one, Beck says when if you have to scroll through, the first 1,000 lines of a very long C# unit, before you come to, oh, this is where it starts, this is what it actually does, like quite a lot of cognitive load. You keep waiting to see, am I missing something? So once you've discovered it, for those who come after you, go and take that and move it to the top. And it shouldn't break anything because we're just organizing the code a bit. It does have a subtle thing as well that it does. It's made you've been reading everything anyway. So you kind of know what you're doing. And the other one, which is a little bit more important, is I don't know if I would be moving methods around much, but I might if I get irritable enough, right? If it's really like, just put all this stuff together, then I'll understand what it does. Is declarations and usage. Please, I hope we're not still declaring our variables at the top and using them 1,400 lines later. We used to do that sort of shit. Naming. Naming is your best weapon in making the code cleaner. It helps explain usage, intent, if possible, use ubiquitous language. Before I talk about the other one, you're probably reading ahead, so let's talk about that quickly. If you've got a big expression with multiple parts, maybe break them up into subcalcs, because then you can name, like width equals part of the expression, width is assigned, height is assigned. And then when you're reading the top one, it'll be, return the width and the height, and oh, that was what the first part was. It's a automatic commenting mechanism, right? Yeah, I know you didn't need all those variables, but if it made it more readable, wasn't that better? I mean, write like you're writing a book in your code. I'm going to give you an ubiquitous language example. The DDD people love this sort of stuff. Repo. If I say repo, does everyone know what I mean? A repository. Typically, we chuck our access to the database in there and away from the domain code. But we also end up then with code that is quite techy. We love our buzzwords. So new customer repo or var cust repo equals new customer repo with whatever you need to create it. And then customer repo dot get by age or something, and it's got parameters. And what you really wanted, what the customer wants, is a report perhaps of um, customers who are under 18. Maybe they sell to, so whatever it is. I'm making an example. So if you said something like the var customers equals new customer repo, that can still be called that. And then you could say something like customers dot junior members. So my list is assigned customers dot. Doesn't it sound a bit more Englishy? Do you feel like you could read it? I'm not asking you to imagine code. Hope you can do with that. So that's one of the challenges. We all get a bit, we like our buzzwords. But let's say you were trying to explain to the customer. So if I returned junior members here from customers, would that be what you want? It's much easier the second way to read it to them. They might even go, yeah, that's right. But if you start talking to them about repos and things, they're going to be, it's all right, whatever, you guys do your shit. So try and get closer. I mean, we work for them, sadly. All right. Comments? So it's worth a little rant. Get rid of any redundant ones. What's a redundant comment? Says what the code does, you can read. Or it's stale, it's old, or it adds nothing. That's redundant. But add any of the gotchas. So the general rule is, as far as possible, improve your naming and refactor everything till it reads okay and you can kind of tell what it's doing with no surprises. But if there are inherently surprises, there are sometimes. There's something really weird in the code and it's there because of, I don't know, performance or some quirk of the infrastructure or some dependency that probably shouldn't be there, but hey, life's reality. Then put in the why comments. I like why comments. Why is this being done like this? When it's going to catch me out. But absolutely no how it's being done or what is being done comments, okay? That would be my rule. Say, it's your heuristics you're going to build after this. But why rather than what is a good guideline. So in getting to clean code, and like I said, those were baby steps. You also need to recognize code smells, the opposite of clean. Stinky code. I mean, absolutely no unit tests. If this is the first time you're looking at it, you're going to be like, oh, okay, that's a smell. I'm a big fan of single responsibility principle. Small pieces of work that is testable. What is a single responsibility? Well, that's a heuristic again. I normally model it on one business result. So if I have a process that has sort of 3 business steps in it, I prefer 3 methods, each one testable. So I can see step 1, got it. Step 2, But a lot of people start thinking it just means make it smaller and smaller. That doesn't help. You end up with one statement per method. How does that help us, right? So again, you've got to have a heuristic. You've got to have your own guidelines in your head that tell you what's reasonable. The side effects are when a method does something. Well, the UI is a side effect, right? You're not going to get a result back from that method. It's going to go do it itself. It's going to put pixels on the screen. Okay, so we refer to side effects for that stuff. But there are places where no parameters and no returned value. You're like, what is this thing doing? Because I don't know what data it's acting on. Because there are no parameters. It must be globals and hidden things, or it's getting more stuff itself off. I don't know, it was not only displaying to the screen, it's also getting the cookies or the local data or the something else. So it's doing lots of stuff. So it's not single responsibility, probably. And you have no idea if it did it successfully or not, because nothing comes back. So it's just a smell, okay? The C# is old C# code. Those voids, man, everywhere. You just know the whole darn thing is dependent on globals. Terrible. Get rid of that stuff. Duplicated, the stuff not being dry. I've given you a strategy. Don't Don't freak out that you've got to find every duplication at once. Just handle it. But yeah, I hate seeing lots of duplicated code. And then tramp date is a nice word. The idea of a tramp was someone who jumped onto a railway carriage and rode along for the ride. So you've got method A equals method B equals method C, and it's passing quite a long parameter list. And let's say one of the parameters, nothing happens to it in A. It gets passed along to B, still not in use. It's passed along to C, still not in use. And then maybe finally it comes to something, and now it's needed. You've definitely got some coupling. There's a smell there. You've got something that's tramping along for the ride, and it's not really needed in most of the places it's being passed to. And maybe your way you're linking stuff is creating dependencies. It's a smell. Okay. Well, we got to talk about AI. So AI writes terrible code, right? It's very seldom writing clean code, unfortunately. There are things you can do. If you aren't already, I'm sure most of us are using it for all the boring stuff. Make me a POCO, whatever. I mean, we use it like a little mini tutor, the how do I's. My heuristic, my rule on this one is I never put anything into my actual code until I understand it. So just because AI told you this is how you do it, please don't believe it. Just remember it lies through its teeth. Okay. It does, right? Yeah. So make sure you understand it, then you can use it productively. And another cute trick is once it's given you something, ask it to refactor it. It might give you a better version. It's quite an iterative tool, AI, so keep at it. Right, so those are things you can test your decisions against. Will my future self understand this? Consistent, readable, organized well, and testable. I snuck that in at the end.